This is a change of units, and I will let you to do this. You can look in the textbook how to actually do all of this change of units. The somehow the for number 8, I missed there the heading of the problem, but we did this in lecture. This was done in lecture. This was done probably on Wednesday or Monday, I forgot. This is what I call tip of the iceberg. And actually the answer should be the same. And this one was also dealt with in lecture. This is a problem of displaced fluid. So what is the depth? Well, the barge will be this. So this is the depth. So this is the water here. So you will have that. You will have that. So they are asking for this depth D. And this distance is 19.8 is here. And of course the 9.5. So this is the depth. So this is the level of water. So this will be the 9.5, the width. So the mass, this mass M times G, that weight have to be equal to the weight of the displaced fluid. And the weight of the displaced fluid is the density of the water times G times the volume displaced. And the volume displaced in this particular case is 19.8 times 9.5 times D. So now you find D, because from this equation you can find D. This also is a question of displaced fluid. So because the weight of the displaced alcohol in this case is equal to the buoyant force. So you have now you have a reading in the scale, and then you have the weight, and then you have to have the buoyant force, which is this one over here. So you balance those forces, and then you can remember that the specific gravity of the alcohol is the density of the alcohol over the density of water. This is what it's called here. This is a problem of the continuity equation that we did today in class. The continuity equation has to do with when fluids are in motion. And with fluids that are in motion, what happens is that the product of the area times the velocity remains constant. So in one case you have one area, one speed, and in the other case you have another area and another speed, and this is how you calculate how fast the water will move through the nozzle, and it has to move faster than through the hose because now the area is smaller. This is the same as 11, same equation as 11. And this one, we also did a very similar one in lecture on Wednesday. You basically have to figure it out, what is this density? And to figure it out, that density, you have several options. The pressure here is the same as the pressure there. And the pressure here is connected to the pressure here. in this pressure is given by this H2, but the pressure over here is the same as over here. So you can know the pressure because you know this distance and you know the density of water. Then you can come back here and do it. There's many ways to do it, and it should be pretty easy. So that's going to be all, and I hope it has been helpful. Thank you very much.